Hi. Okay, so in this video we will talk about categorical feature encoding. I had made the mistake of not including it in the last part, but yeah, I suppose we'll talk about it now. Okay, so why do we need categorical feature encoding? Um, First things first is because we actually need to convert these categorical variables to numbers, such that the model is able to understand and to able to extract valuable information, since the most machine learning models can only accept numerical variables, right? So yeah, there are actually many methods to encoding, but in this video I will talk about only four, and I will specifically highlight something that is very important because I actually made the mistake of thinking that what I did and my analysis was binary encoding, when in fact it's simply just label encoding, right? So yeah, yeah, you can see later on. So the data itself is actually an output variable, um, telling us whether or not the breast cancer is actually malignant or benign. And so it's either or, and there are two values. And I thought, okay, this is just binary, right? When in fact it's not. It's not the definition of binary encoding. And I suppose we'll talk about why. And I hope this can be a lesson to whoever's watching as well. Okay, so the first method is actually the uh, one-hot encoding. So for one-hot encoding, we map each category to a vector that contains 1 and 0, denoting the presence or the absence of the feature, right? So yeah, uh, the number of factors depend on the numbers of categories for features, and this method produces many columns that slow down the learning significantly if the number of categories is very high for the feature. Yeah. Okay. So it is actually very popular, and we can represent all categories by n minus 1. Uh, is sufficient to encode the one that is not included, right? Usually for regression, we use n minus 1. We drop the first or last column. Um, and for classification, the recommendation is to use all n columns, as most of the tree-based algorithms builds a tree based on all available variables, right? One-hot encoding with n minus 1 binary variables should be used in like linear regression to ensure the correct number of degrees of freedom, n minus 1, right? Yeah, and the linear regression has access to all of the features as it is being trained, and therefore examines the whole set of dummy variables altogether. This means that n minus 1 binary variables give complete information about and represent completely the original categorical variable to the linear regression. Um, this approach can be adopted for any machine learning algorithm that looks at all of the feature simultaneously during training, right? So yeah, like for example, we have the SVM, support vector machine, or the neural networks, as well as like various clustering algorithms. Yeah. Okay. Okay. And then next up, we have the ordinal encoding. So first of all, what do we mean by ordinal, right? So, uh, so like with you know, ordinal means if something has like a relation to one another. Like for example, 1 is less than 2, 2 is less than 3, 3 is less than 4, right? So yeah, um, we encode the data in the ordinal fashion if um, you know to like so ordinal encoding involves like mapping each unique value, like each unique label, right, data to an integer value. It is actually sometimes referred to as integer encoding, but this is not just simply assigning integer value. Um, This is only appropriate if there is a known relationship between the category, right? Like for example, something is lesser than another one, you know. If there's a known relationship between the category, um, if the relationship exists, right, for the variables, for some of the variables, it should be harnessed when preparing the data. Uh, okay. Mm, okay. So um, we yeah. The thing is, that particular relationship may be useful if you want to train the model, you know, because it does indicate something, right, in the data itself, you know. Like, for example, maybe when uh, you know, when you analyze salary rate for from like a data of people with different jobs and different amount of experience, right, and you know how you know, the amount of experience is actually an ordinal data, right, because it actually matters how long you've been working in that job, you know, in that specific job, you know. And uh, yeah, you would want to use ordinal encoder for that. Yeah. Yeah. Okay, so all right, label encoding. So label encoding is simply assigning a value from 1 through n, where n is the number of categories for a feature. Let me just add. Yeah. A major issue with this approach is that there is no relation, right, or order between the classes, right? So essentially, um, this is what I did, right? So I map malignant to 1 and benign to 0. It's like positive or negative, right? And so um, watch out, because some algorithm might consider uh, this encoding as having, you know, some order or some relationship, when in fact they don't, and this will, you know, ruin your whole model, right? And it could be very misleading, you know. And last but not least, we have the binary encoding. So for the binary encoding, it essentially converts a category into binary digits. Each binary digit creates one feature column, right? So if there are n unique categories, then the binary encoding results in uh, a log base 2 of n features, you know. And yeah, uh, for binary encoding, one has to follow the following steps, right? Okay, so first, the categories are first converted to numeric order, starting from 1, and then those integers are converted into binary code. Like for example, 3 becomes 0 1 1, right, and 4 becomes 1 0 0. And then the digits of the binary numbers form separate columns, you know. So yeah, you have like separate columns for each of the binary numbers, depending like on like how many categories you have, you know. So yeah, that's what's called the binary encoding, when it's actually a lot more effective from, you know, the one-hot encoding, since this will require fewer feature columns. For like, for example, let's say we have 100 categories. One-hot encoding will have 100 or maybe 99, because like n minus 1. But for binary encoding, we will need only 7, right? Only 7 features, because, you know, if you try to like represent it, represent the encoding, and you know, and represent the categories in binary encoding, it will just have 7 features, you know? So yeah. All right. Okay. So yeah, I suppose that's it for this video, and I'll see you in the next one.